Hey guys, and welcome back to another YouTube video. So this is gonna be a really exciting and a cool video because I will be creating a game where a neural network will be a controller. I know it sounds kind of weird, but the way it works is that if you kind of lift up your left arm, then the character will move in the left hand side direction, and the same for the right. Like if you lift your right arm, then your character will move towards the right. So that's kind of the idea behind this game. So yeah, that's gonna be pretty cool. So that's what we are gonna be making in this tutorial series, a neural network game. So right now, what I'm gonna do is I'm just quickly gonna kind of explain to you how we are gonna approach this problem, and then we will actually uh, work around and actually I'm sorry for that, and actually create this. So the first thing that we want to do is we want to have a neural network. We want to have a neural network. Now that's pretty obvious. Now what we want this neural network to do. So what we want is we want this neural network to first of all uh, save a model, save a model, and then what we want is we want to have a saved model that is applied to our game real time. But the only way we can do it is we need to make it so that this saved model communicates communicates. I'm sorry, there will be a bit of a delay over here. So yeah, so the saved model will communicate to an open CV video stream. So we are gonna have a video stream of open an OpenCV video stream, and our saved model will communicate with that OpenCV video stream. So that's that. And the next thing that we will have is this OpenCV video stream will constantly send data to a Pygame window. And that's basically how we want to approach this problem. So now we have actually looked at how we want to create this game. Now what game is it gonna be? I'm gonna go for a very simple game for this tutorial, and I'm just gonna go with Chrome Dinosaur. And instead of moving left and right, there's just gonna be one control, up or down. So like jump up or jump down. So if you raise your hand, then it's a jump up, and if you lower your hand, that means it's just your normal position. So I'm just gonna write it over here. The game of choice is Chrome Dinosaur. The a cool way would be if we constantly read data from the Actually, we don't even need to do that. If we, the cool thing would be maybe at the end I will show you this also, is using the OpenCV video stream. We automate the actual Google Chrome Dinosaur. That'd be cool. Not exactly automate, we still have to raise our hands and stuff, but yeah. So that's basically the entire idea, and now we need to implement it. So, this is actually just a tiny bit advanced. It's not something that I would want really just a beginner in neural networks to dive into. Uh, Sorry for that. So I would recommend that you watch through some of my previous videos on my channel before you actually take this course, because otherwise you will not understand some of the things which is you don't want that. So yeah. So we are gonna be using a CNN or a convolutional neural network, and I think the way we are gonna have is we're gonna have one uh, oops one conv 2D of 128 by 3. Then we are gonna max pool it, max 2D with a 2 by 2 pool size. Okay, what did I do with the 2 by 2? And we are gonna take this and we're gonna add like three of them, and each time we are gonna reduce this. So after 128 we will make it 64, and then we will make it 32. There is a chance we might not need this 128 one, but we will see. And the data set we will also create by ourselves, so that's pretty cool. So yeah, that's actually the entire plan for this. So yeah, that's basically what I think will be the optimal way to approach a problem like this. So that's pretty cool. Now let me just close this. Alright, so let me just stop that. Alright, cool. So let's just close quick time now. I don't want to save it. Alright, and I'm just gonna open up the terminal window, and I'm just gonna cd to desktop python. Actually, yeah, I'll just make a directory called neural network controller, and I'll simply copy this cd to that. So as you can see currently, if I just run ls, this is an empty directory, so we will just say touch net.py main.py. I think that's all, and I'll just say make a directory called assets, where we'll have all of our game assets, and I think that's all we need to get started. Actually, that's pretty cool. So yeah, so now let me just zoom in real quick. Alright, so the first thing we want to develop before we even go and make the neural network is the dataset. So we need to make another directory called dataset, cd to dataset. Again, as you can see, it's empty, so we need to make a directory called jump. Okay, what happened? Make a directory called jump and make a directory called normal. Oops. So now as you can see, we have these two directories called jump and normal. Obviously these two directories will be empty, but yeah. So now what we want to do is we want to shoot two videos, one for jump and one for normal, and we just want to add them to these directories. So what I will do is I will just open up photo booth, photo booth. Alright, and I just want to shoot a quick recording. Alright, so I'm just gonna go over here to video. So we want to shoot a quick video, and I'm just gonna quick shoot like a really quick video where I'll just have like raised my hands, and that's basically what it's gonna be. So let's do this. It's important to go fast. You don't want to shoot a really long video, cause now I know what some of you might be thinking. Why did you shoot a video right now? Because what we are gonna be doing right now is we are gonna take this video, we are gonna take its frames, we are gonna split each and every of those video frames, and we are gonna end up with a data set. Don't worry, I know it sounds a little complicated, but it's actually really simple to do. So I'll just go to jump, because this was the jump video, and I will simply just add it over here. Just a simple drag and drop, nothing crazy. And it's important to go fast. You don't and I'm simply just gonna rename it to like 0.mov. Alright, cool. So now I'm gonna shoot another video of mine where I'm not gonna be doing anything. Like I won't have raised my hand. Alright, so let's do that. Alright, cool. That's done. Now let me just drag and drop that. Just take that image, put it into normal. I know it kind of looks stupid, but that's how it's done. And I'll just make it 0.mov. Cool. So now what we need to do is I'll just open up Google Chrome real quick. Then Chrome. Cause I actually need to figure out the command to actually do this frame splitting thing. Because I know, like, I have done it multiple times, but I still, for some reason, just can't figure out the command for some reason. Is it like, it's a pretty long command. So, we're gonna be using ffmpeg. So, I actually know a website. I'm more ffmpeg. So on Mac, just search for this iMore FFmpeg Mac split video frames, and literally just click on the first link. There are a lot of different ways, people approach this problem. They use some various commands. I like to use this command. Let me actually show you that. I don't know why I can't find it right now. Where is it? Okay, I don't know why my Chrome is lagging a bit. I think that's why. So we actually need to copy paste the command, otherwise this won't work. Alright, there we go. That's the command. Just take this command, copy that, go up to your terminal, and you're gonna navigate to this directory. I'll just do that, and I will just make this 0.mov dot. I will also just copy this name so I don't need to type it again. And then just click enter. That's all you need to do. Pretty simple stuff. Now it does take a second or two, but as you can see, it's working perfectly. And there we go. So now if I just run ls, look at the number of pictures we have. Now I'll just do one more thing. I'll just say rm 0.mov. So now I don't have 0.mov because rm basically removes a file. So now if I run ls, I will cd to normal. I have my 0.mov over here. I am gonna run this file in my normal directory now. So now as you can see, I have these many images. I'll just go rm 0.mov ls. Now I don't have that, and there we go. That's our data set. That's literally all we needed for our data set. Pretty cool, right? So now we can focus on the actual code. So I'm just gonna say nvim net.py. You can use anything that you like. I want to use this for this video series, and just add number lines and set the color scheme to minimalist. Oops. Color scheme minimalist. Cool. Alright, so I think I'm just gonna go full screen so you guys can actually see this. So let's first make the import. So we are gonna be using TensorFlow, so I'll just say import TensorFlow as df from TensorFlow import keras import os. Now os we are just gonna be using for testing purposes, we are not really going to be using it like for anything else. Import numpy as np uh, from matplotlib, import pyplot as plt from tensorflow.keras.preprocessing.image, import image data generator, and one final import from tensorflow.keras.preprocessing.image, import, actually not, it was, what was it? Actually, it was just tensorflow.keras.preprocessing, uh, import image. And that's, I think, all the imports that we need. The reason why I'm not really getting all of this auto completions and that stuff is because I literally just like a few days ago I upgraded to macOS Monterey or whatever that name is, and for some reason my code completion software kite, it does not work. Like, for some reason the icon does show up, it does work with VS Code, but it doesn't work with Vim, NeoVim, Emacs. Not actually, not Emacs. I don't even use them. Uh, Vim, NeoVim, it doesn't work with that. So yeah. So we are just gonna be doing the rescaling the training data. Now, since we don't have any validation, testing, anything like that, we are just gonna be doing it with the training data. So training underscore img is equals to image uh, data generator rescale 1 divided by 255.0. Now we can go and look at creating the training data set. We can just say train underscore data set is equals to train underscore img dot flow from directory, and here you wanna put in your directory path. So I'm just gonna open up find go to desktop, python neural network controller, and so it's dataset, it's just dataset, oops, just put in dataset over here, and we are gonna be passing it a few parameters, such as the target size of the images that we want to load in. So I'm gonna load in 150 by 150 images, I don't really care, and I'll just load in them with the class mode of binary. And now we need to define the class names. I'll just say class underscore names is equals to jump and normal. Now we can go and creating the model. Creating the model is pretty simple. Now here we need to remember the architecture that we were using. So let me just open up QuickTime again, and let me just quickly new movie recording. Alright, there we go, cool. So let me just show you what we were going with. So as you can see, this was our plan. This was our plan. So we are gonna go this many, then 64, then 32, and this is like a maybe. So yeah, So let's actually work on that now. We can just close quick time now. We don't need it. Alright, so let me just alright, let me actually just open this up over here. Actually, no, it's okay. Alright, so we'll just say model is equals to keras dot sequential, and in here we will just say keras dot layers dot conv 2d conv con 2d, and for now I'm not gonna add the 128 uh, convolutional layer. I'm sorry, I messed up my speed so bad. But we will see. If we don't get the accuracy, then we will add it. Now, but we do need to match spool list. That's something that I will do for sure. And you know what? I don't care to type that out again. I'm just gonna copy that. I really don't want to type that out again. Alright, now let me just make that 32, and we will just say keras dot layers dot flatten and keras dot layers dot dense with a 2 and activation of sigmoid. So now we can go and watch and do the process of actually compiling the model. Compiling the model. So I'll just say model dot compile, and I'll just say optimizer is Adam. The loss will be binary percent should be, and the matrix will be accuracy. Awesome. And we can go and fit the model. So you can just say model dot fit train underscore dataset epochs is equals to 5. Do we need a batch size? I don't think we need a batch size, but we will provide a batch size over here. A batch size of 32. Actually 32, you know what, not 32. Let's provide a batch size of 40. Alright, cool. Alright, let's just manually just do this. Cool. So now we have done that. We can just go saving the model. We can just say model dot save. What was that? Let's just save it as controller neural network v1.0, and we can also get the model summary. Getting the model summary, so we can just say model dot summary, and that's all we need to do, and we can run this. Awesome. So now let's just run this model and see if everything works. Alright, it's taking some time. Come on. I think using the terminal while using Vim to run a neural network isn't something really good. So I think I'm just gonna WQ out of here and open up item. So dismiss step. Oh, come on, what's happening to my typing? Sorry for that. So I just cd to Python. Oh, come on, what's happening? I'm just gonna cd to what was that? Come on, where's that? And the editor. Can't find it. Okay, let's see it over here. Neural network controller. You know what? I'm just gonna copy this name and cd to that directly over here. Cd neural network controller, and I'm just gonna open up net.py over here, set number and color scheme. Pretty cool. And I can simply just go python 3 net.py over here on my terminal. Working. Perfect. Cool. That's cool. Everything is now all set. As you can see, we haven't really lost any code. It's all good. Oops. What did I do? Oops. What did I do? I think I got rid of the things. Yeah. Oops. Shouldn't have done that. Alright. Train underscore img is not defined. Oh yeah, it was training img, not train img. Oops. Training. How do you spell that? Training img. Cool. Let's run this now. Hope that it works. I'm pretty sure it will at this point. I don't think there are any errors. But can't really get very. Okay, I think I know the issue here. It's with the loss function. I have run into it way too many times. We can just change it up to sparse categorical gross entropy. I think sparse categorical isn't a really good choice for this. It should be binary. But I don't know why I keep running into this error. If anyone knows like a workaround or a solution to this, comment down below. I would be really happy. Alright, there we go. As you can see, it does say found 203 images, and it does start the epochs, and there we go. As you can see, we have our epoch running, and it's actually a pretty quick to train model. It isn't something that takes a day, and believe me, I have trained models that like training them takes up a whole lot of time. So for models like that, what I like to do is I use Google Colab, or you can also rent a few GPUs. Even that's a really cool option, something that I like to do. You can sometimes or you can uh, if you have like some of your friends or some computer like that which actually has a lot of GPUs, then you can surely uh, borrow it, because actually training really heavyweight models on a Google Colab is also something that's are not possible. They do have a RAM and a disk space, and you can't actually overflow that. So yeah, so it's not the best option, but for like most things, it's actually pretty cool. So we are running into a pretty big loss. So I'm pretty sure this is like a overfit model. This is a real overfit model. Like it doesn't show it, like it doesn't have like that 1e loss, it doesn't have an exponential loss, but as you can see from the loss, I'm pretty sure it's overfit, and as you can see, like 33 why. So I like the loss that I wanted to get to was like a point 0.1 or a 1, and the accuracy that I wanted to get to was about 99 or 100. So I think we are gonna have to mess around with the number of epochs on this thing, because 5 epochs didn't make it. So what we are gonna do is increase them, make it 7. Uh, I think 7 is gonna work. Okay, what just happened? Oops, what's happening? Come on, what's happening? Alright, there we go. I'm just gonna go python 3 net.py, and I hope that 7 epochs does work. I really do hope that, because if 7 epochs also doesn't work, then I think I'll have to mess around with the actual model code and this stuff. Like I don't really like to play around with it. I just like to increase epochs, because yeah. So if 7 epochs doesn't work, then I will probably mess around with the model. If that doesn't work, then I'll probably tune these hyperparameters. Wait, wait a second. Dude, what? That's a syntax error. If I've ever seen one. There we go. That was a pretty big syntax error. I don't know how I managed to do that. Alright, we are having a 72% loss. That's horrible. 56 still horrible. We got to reach at least 10. Like you, like 10 at the most. I can't have a loss about 10. Like it's not because we are doing anything too serious here. We are literally just controlling a game. But you know, if it's higher than 10, then we are gonna run into incorrect predictions left and right, which won't make the game fun. You know, otherwise, why couldn't I just play with my computer keys? Okay, we are having a 44% loss, which is incredibly bad. At like 44 is really bad. I got to reach at least 10. Uh, like So as you can see, there's also not a huge decrease in the loss. It starts at 72. Second epoch, it also remains at that. Then decreases by just 20, reaches 50, decreases by only 3. Then again decreases by like 12. Now it decreased by 11. So it's like the rate of the decrease is actually not something that I like right now. It's I was expecting a bit of a better thing. You know what? 22, it's bad, but I think I'm gonna make do with it. For now, I think I'm gonna make do with 21% loss. Cause otherwise I'll have to give it 10 bucks, because something I think, like initially I thought that maybe I'll have to play around with the e-box stuff like that. But now that I look at it, I think 10 epochs would have done the thing. It would have reached like, I don't know, 1 or 2, something like that. So as you can see, we have a really just a simple model architecture. Our model architecture is incredibly simple. We don't have many training params. So yeah, that's pretty cool, right? So that's pretty much the actual model part. So what I'm gonna do now for right now is I'm just gonna comment out a few lines of code that I need to comment out. So what I need to do now is load in the model. Now for that I'm just gonna go to line 5 because I need to add a line. So from TensorFlow TensorFlow dot keras dot models dot load, actually dot models import load underscore model. So now we can just go to line number 35 and we can simply just say model is equals to keras dot models dot load underscore model, and we can simply just pass it this model name. So we can just yank it and paste it. Okay, what just happened? I didn't yank the entire line, did I? Go to visual, yank, and paste. Oops. There we go. Alright. Uh, and over here I'm just gonna, I am not sure if this will work, so I'll just say print model loaded, ready for predictions. And over here I'll just run this again. And there we go. As you can see, it does say model loaded ready for predictions, and that's exactly what we had printed out over here. So that means that our thing worked, which is pretty cool. So now we just wanna and you know what, I think, like, I know prediction doing is pretty important. You know what, I think I'm gonna do it. So let's do it. You know what, one thing that I also do wanna do is just see evaluate, given the data that it has already seen, uh, is it able to do any better in the evaluation? Because I don't know, man. I think it, I don't know. I know it won't be able to, but I just wanna check it out. Train data set. Let's run that. Alright, let's have a look. Ooh, that's pretty cool. Alright, that's good, that's good. Alright, cool. So now we can actually, this was kind of like the predictions only. It basically evaluated the entire thing. So we don't need to do predictions now. Cause basically if you don't know what evaluation does, what that model dot evaluate thing that I wrote did, was it looked at the entire thing and then it just calculated how much it got right, how much it got wrong, calculated the accuracy based on that. So it did all of that for us in that just one statement. But I get it, some, you guys would like to see exactly which image didn't get incorrect. So I am gonna do that now. So what we need to do now is I just need to head over here, and I need to check a few things. So over here in dataset we do have two directories. So I'll just say dataset slash jump, and I'm just gonna cd dot dot out of it. Next I'll just say for I in os dot list dir, not dir, and not list dir. This should be test dir. Oops, sorry for that, guys. So test dir, and I'll just say image is equals to image dot load underscore img, test dir plus I plus slash slash target size is equals to 150 by 150. Then we can just say x is equals to np dot image to array image to array image. I think this is incorrect, so I'm just gonna run this. Then I will just say x is equals to np dot vstack. Actually no, it should be expand underscore dimes, and I also need to make it something like this. X axis 0, numpy has nothing image to array. Alright, let's have a look at the code. If you think that I don't use my old source code, then you are in a serious misconception. I do that all the time, and that's what I'm gonna do right now. Which one do I use? Just gonna use my live face mask detector now, I think. Which one was that? Net.py, I guess. Let's just open it up in IDLE real quick. Come on. Hey, what? There we go. Where did we do that? np.image to image. That's exactly what I have done over there. Oh, wait a second. Let me just. Okay, why can't I select these 3 lines of code? I seriously hate IDLE. I just don't like it. It's pretty bad. Let's actually just get rid of this. Oops. Oh, come on. There we go. Paste it here, right here. Just do that. Just do that. Do that. Do that and do that. Okay, I think I did not copy this. I was a little bit confused why I printed that out instead of that. So yeah, now I know. Command C that. Come on, why am I not able to do this? Maybe I'll have to zoom in and do it. This is so weird. Alright, I think now you will be able to do it. Oh my god, this is really bad. I never knew ideally had actually gotten this bad on the Mac. I'd never use it. So I'm just gonna go control V actually control V. So I have just pasted all of my IDLE code over here. And I'm also just gonna get rid of this code. Pretty simple stuff. Let's get rid of ideally. And now that we have our images, we can just say prediction. The prediction is equals to the model dot predict, and we want to predict on the images, and we obviously want to print it out, right? So I'll just say print. Now we just won't print the prediction. Just see what we do. We will just say class underscore names np dot arg max prediction, and now we will run that. All right, pretty cool. Prediction is not defined. Okay, maybe I spelled it wrong. Prediction. Predict. Okay. Prediction. Spelled it incorrectly. Let's just run it again. And let's also have a check. See if this video is getting too long, and it is. But it's okay. Like this series, well, it is gonna be kind of long. Prediction isn't defined. What are you saying? I literally just do. Alright, I'm just gonna copy that name and just paste it over there. I can't. X and P. Okay, I kind of screwed that up. I have to add that. Done. Oh, come on. How many errors do I have to deal with right now? That's that, that's that, that's that. Don't need that. Alright, cool. Let's see if this works now. There we go. Wait, what the hell is happening? Reddit. Dude, I spelled it wrong again. Are you serious? I think I undid a lot. This video is seriously just a montage of me acting like an idiot. Like half of this is I know it's because I literally don't have autocomplete now. I really have gotten spoiled with all of that auto completions that I would always get. Like seriously. So you know what? I'm just gonna line letter by letter. I'm gonna copy that name. I'm pretty sure I didn't screw that up now. Because if I have now, then I don't know why I can't type that name out. Then I'll just